torsion. When the tangential force is applied to a shaft at the circumference in the plane of its cross-section of the shaft due to optical moment about longitudinal axis is known as the twisting moment or torque. Simply he says that when I am applied the tangential force applied on the shaft circumference due to obtained movement, this movement about longitudinal axis, that is known as the torsion or twisting moment or torque. Means you see that is our shaft. Suppose in this shaft I will apply tangential load. You know the tangential load same as the shear force. Because of this tangential means he will apply the load in the surface of the object. So the tangential force due to produce the movement about longitudinal axis, that movement is known as the torsion या twisting moment या torque. So our first thing is the find out the what is the longitudinal axis, what is the transverse cross section. You know, I will write in the note the x-axis are longitudinal axis and the y and z axis are our transverse direction. Mean you see in this shaft diagram, I will draw the x-axis is our longitudinal axis, our y axis is transverse axis, and our z axis are also transverse axis. But movement about only longitudinal axis obtained due to tangential loading, that is considered as a torque, and another movement about y axis, movement about z axis, these movements are not considered as a torque. And suppose the torque, that is the first only one, not a criteria to understand the this is a torque, this is a movement. I am given also a condition, that condition through also you understand or easy find out which movement is considered a torque. That condition is movement are obtained due to load and eccentricity, both are is transverse direction. What I am saying simply is say that the moment means the force into perpendicular distance. Means our movement is dependent upon only two parameters. One is the load, second one is the perpendicular distance. But here are perpendicular distance is replaced to the eccentricity. You know what is the eccentricity? Simply eccentricity means suppose any object are applied load at a center, that is known as the normal loading, but I will load apply some distance from the centroid, mean the eccentricity, that distance is known as the eccentricity because of the load not acted on the centroid of the object. So this load is the eccentric load, but our in this unit in torsion not matter the eccentric load, here only matter the eccentric load. When the load are acted in torsion, produce torque on the shaft only required from the eccentric distance. When the perpendicular distance are replaced to the eccentric distance, mean our eccentricity and load. When the both are, you understand what is the eccentric distance and eccentricity, and our movement is the dependent upon two parameters. First one is the load. Load is the tangential force, but our perpendicular distance is our eccentricity. Both the load and eccentricity both are acted in the transverse axis or transverse direction or transverse section, then the produced movement is considered as a torque. You see in figure in bottom second figure I will draw a segment of the shaft. In this shaft you will see x-axis, our x-axis is the longitudinal axis, y axis our transverse, z axis our also transverse axis. You know, I will apply load py, this py in the direction of y, this y is the transverse direction, and ez eccentricity also in the parallel of the transverse direction. So the load and eccentricity produce the moment. I will write mx is equal to py into ez. That moment considered as a torque, because of here are in given diagram our load and our eccentricity both are acted in the transverse direction, and this transverse direction applied load and eccentricity to obtain moment in about longitudinal axis, that axis x-axis. So I will consider here as a this moment is a torque. I hope you understand what is the torque and what is the condition of the torque. Our next topic, how can I will understand what is the moment, how can differ our torque, our moment differ from the torque. So that also I am given the condition that through you judge the of this moment is not a torque. What is the condition? Moment are obtained due to load and eccentricity both are transverse direction and longitudinal direction. Mean he said that any one of the, you know, our moment is dependent upon two parameters. First one is the load, second one is our torque. No, eccentricity. First one is the load, second term is the eccentricity. Any one is acted in the transverse direction, another one is acted in the longitudinal direction. Means suppose I am take a load in transverse direction and eccentricity in longitudinal direction, then produce a moment, that moment not a torque. That is the condition of the moment. See in figure, that is our object. I will draw the section of the shaft. You will see I will apply load px in the direction of the x-axis. You know, our x-axis is our longitudinal axis, and you see eccentricity ey, eccentricity first letter e, eccentricity in y direction, that produce moment about my px into ey. That moment considered as a not considered torque, is considered the moment, because of, you know, our load in the longitudinal and our eccentricity in the transverse direction. And also in second diagram you see I will load apply in the transverse direction, our eccentricity x direction, due to produce moment about y py into ex, that is considered as a moment, not considered here torque, because of here one load is transverse direction and eccentricity in the longitudinal direction. So I will not consider as a torque, he is considered as a moment. And in last figure I will also, here are loading in the y direction, x direction, px in the direction of x, that means longitudinal direction, longitudinal axis parallel, and eccentricity ez in the transverse direction, and this produce the moment about z. That moment, that is not considered as a torque, he is considered the only moment. I hope you are understand the moment, that moment how can differ from the torque.